Alright, so this is going to be section 4.3, the circular functions. And before we really talk about the different types of functions, we have to talk a little bit about some vocabulary so that we understand what a question might be asking and what they're talking about in terms of an angle. So, they want you to think of an angle in terms of a rotating ray. So, I'm going to just draw a coordinate plane here. And if this is our original spot, this is where we're always going to start. I'm going to try to use a different color here. For a rotating ray, you're going to start here, and then it's going to rotate in this direction. So maybe it ends here, or if it keeps going, it can end here. So wherever the angle starts, its starting position, which is usually on the positive x-axis, that beginning position is called the initial side. It's rotated about the vertex, which again is generally the origin, but it can change. It's rotated about something called the vertex, and then its final position, wherever that ray ends, so for example if it ends here, this is called the terminal side. So when we get angles, we can see that positive angles are formed by rotating counterclockwise. So this would be our initial side, and this would be the terminal side. And then we can see that you can also get negative angles, and they're made by counterclockwise rotation. So if that's our initial side, this is the terminal side, we're rotating it in the other direction. So those are clockwise rotations cause negative angles. So we have something called coterminal angles. And what coterminal angles are two angles that have the same initial side and the same terminal side, but they don't always have the same degree or radian measure. So, for example, if I draw my axis again, and I'll try to change the color here, I have my initial side, and I could draw an angle at 90 degrees. Yes, we agree this is a 90-degree angle. Well, this is one angle. I can draw an angle that's coterminal to this. A coterminal angle to 90 degrees might be 450 degrees. And I'll use a different color to show that one. So it's going to have the same initial side, but this time it's going to rotate all the way around 360 degrees, and then it's going to rotate another 90 to get to there. It has the same terminal side as well, so they both started in the same position and they both end in the same position. But these are coterminal angles. So 90 degrees is coterminal with 450 degrees. And I'll label this one as 450. Now it can also go in the other direction, so I'll use green to go in the negative direction. Negative 270 degrees is also coterminal with these two angles, negative 270, because I can start again on my initial side, the same initial side, except this time I'm going to go this way, 270 degrees, and I'm going to have the same terminal side. So I've created this angle three different ways. So 90, 450, and negative 270 are coterminal angles because they're all multiples of 360. The same thing can happen with radians. So for example, in radians, you can have coterminal angles. If I start with pi radians, we know that an entire circle is 360 degrees, or 2 pi radians. So pi radians is coterminal with 3 pi radians, and is also coterminal with negative 99 pi radians. Right, because I could go in the other direction, that's pi, and then if I went around 99 times, or 98 times I guess at that point, you would end up in the same place. So these are multiples of 2 pi radians, these are multiples of 360 degrees, a full circle. So those are coterminal angles. So for our first example, let's try to think of some angles that are coterminal, and you always want to name some positive and some negative angles that are coterminal with 30 degrees. So what are some angles that are coterminal with 30 degrees? Well, it's really easy to find these because all you need to do is add, when it's in degrees, add 360 degrees, and you would get 390. And then in order to get some negative ones, you could just take away 360 degrees, and we're going to get negative 330. So that means that 30, 390, and negative 330 are all coterminal angles. You could do the same thing with, if I wanted to find coterminal angles to 150 degrees. What angles are coterminal with 150 degrees? Well, if I add 360, I get 210. And then I could also take away 360. And I'm going to end up with, I think, 570? No, I'm sorry, 510. I'm going to end up with negative 510 if I take away 360. So these, negative 150, 210, and negative 510 are coterminal angles. Let's do the same thing. Let's try an example with radians now. So my radians example is going to be 2 pi over 3. I want to find some angles that are coterminal with 2 pi over 3. So we know that we have to add 2 pi to this to get our answer. So I'm going to add 2 pi. But I can't just add 2 pi because they don't have like denominators, so I'm going to have to change this to the same denominator. And that's really the same as 6 pi over 3, right? 2 pi and 6 pi over 3 are the same thing. So now I'm going to add 2 pi over 3 plus 6 pi over 3, and I'm going to end up with 8 pi over 3. So 2 pi over 3 and 8 pi over 3 are coterminal angles. I'm going to do the same thing this time, except this time I'm going to subtract 2 pi. And instead of writing 2 pi, again, I'm going to just write 6 pi over 3, since they really mean the same thing. And when I subtract 2 pi over 3 and subtract 6 pi over 3, I get negative 4 pi over 3. So that means that 8 pi over 3, negative 4 pi over 3, and 2 pi over 3 are coterminal angles. Here's another type of question that you're going to see in this section. The question will ask you to evaluate all the trig functions. So it's going to say, let theta be the acute angle in standard position whose terminal side contains the point 5, 3. So remember, standard position means in the first quadrant, looks like this. We know that this is the initial side along the positive x-axis, and the terminal side is the side that moves, and it says that the terminal side contains the point 5, 3. So we've just created our triangle. I'm going to just try and draw a dotted line there. That's good enough. This is our angle theta. So now we want to evaluate all 6 of our trig functions. Well, since we know this is the point 5, 3, I know that this value here is 5, and I know that my y value here is 3. So now I can pretty easily find what my radius is here by doing Pythagorean theorem. 5 squared plus 3 squared equals whatever my c squared is. Do c squared or x squared, whichever works for you. I'm going to get 25 plus 9 is c squared. And this is 34 equals c squared. If I take the square root of both sides, I get that this last side is equal to the square root of 34. Now I can pretty easily evaluate all of my trig functions. I'm going to do sine of theta first. So sine, remember, is opposite over hypotenuse, so this is going to be 3 over the square root of 34. But since I have a square root on the bottom, it's irrational, and I need to make it a rational denominator, so I'm going to change this to 3 root 34 over 34 by multiplying by 1, or square root of 34 over root 34. And I'm going to do the same thing in order to find the cosine and the tangent and cosecant, secant, and cotangent. Try to find all of these and I'll write in the correct answers for you. And here are all the correct answers. Make sure that you check your answers. You've rationalized all of your answers because all of mine are in rational form, so you might have to multiply by 1 or square root of whatever over the square root of whatever in order to get a non-square root on the bottom. So checking all of those answers. So sometimes you get the same problem, except now we have a negative number. So now it's saying that the terminal side, remember this is our initial side, the terminal side includes the point -5, 3. So here's where we use something called reference angles. So this is actually theta. However, wouldn't it be a lot easier if we used this triangle here? So now we're going to change this to theta. But you need to remember that this side is actually still -5. This is still 3. And then we already found from the last problem that the hypotenuse has to be the square root of 34. So now this time, try to evaluate all 6 of those trig functions using this information. And here are all of your answers for those 6 trig functions. What you really need to understand here is that they're all the exact same answer, however, we've changed some of them to negative. So you can see that cosine, tangent, secant, and cotangent have all been changed to negative answers. And we're going to talk about a little bit about why that is coming up in the next section. But you do need to remember that this is now a negative number. Even though this is our theta, we can use this as a reference angle in terms of getting all of our 6 trig functions. So this is something that might be helpful to write down. You can pretty much use this for any angle. There's all 6 trig functions for any angle on the coordinate plane. So your angle can be all the way over here, or it can keep going all the way around. Whatever your x value is, whatever your y value is, and the radius of that trig function. So a lot of times you need to figure out what the radius is, just like we did in the very first problem. You have to use Pythagorean theorem in order to find what the radius is. Once you find all 3 of those values, it's pretty easy to write all of these functions down. If for some reason one of them is not defined or is equal to 0, one of your trig functions or a few of your trig functions may be undefined. Remember, the radius is always going to be a number bigger than 0. It's never going to be 0. You can never have a negative or a 0 radius. But some of your x or y values might be negative or 0. If they happen to be 0, some of them are undefined, which is why I wrote when x is not equal to 0 down here and right here, and when y is not equal to 0 here and here. If for some reason, say y is equal to 0, and we'll look at some of these examples in a little bit, if y is equal to 0, you can't do some number divided by 0, so that means the cotangent function would be undefined for that example. Alright, so in this example we're going to be evaluating trig functions of 315 degrees. So, we know that this is our initial side. I measure 315 degrees all the way around to get my terminal side. However, I notice that it is a little bit easier to use this triangle, and we're going to call this a reference angle. So, what is this angle right here? If you can't think of it right away, you might have to do 360 degrees, take away 315 degrees, and you're going to get that the reference angle is 45 degrees. So we're going to use the reference angle of 45 degrees in order to evaluate all 6 of these trig functions, but we just need to remember that this is our x value is +1, and our y value is actually -1, and maybe I should write the +1 up here. Since we know that this is a 90-degree angle, and this one is 45 degrees, you know what this is, right? It's 45 degrees as well. Well, this is a 45. So we know that this is one of our special triangles. This is a 45, 45, 90 triangle. If this side is 1 and this side is 1, you know that the hypotenuse has to be the square root of 2. Now, if you didn't remember that, you could do the same thing that we've been doing to find what the radius or the hypotenuse is. 1 squared plus 1 squared equals c squared. That would be 1 plus 1 equals c squared, so 2 equals c squared. Square root of both sides, you would find that the hypotenuse is really root 2. So you kind of save yourself some of this work if you have already memorized that type of triangle, which if you haven't yet, you will. So now we can use these and what we just learned in the last slide to be able to really easily evaluate all 6 of these trig functions. We know that our x value is 1. We know that our y value is really going to be negative 1. And we know that r is the square root of 2. So now you should be able to evaluate all 6 of those trig functions, and I'll write the answers here for you. Okay, so now you have all 6 of those answers there. Remember, once again, I did rationalize all of my answers, so if yours don't look the same, you might need to rationalize them first in order to get the right answer. So this time, I left out what the degree measure was. Since the question says evaluate trig functions of 315 degrees, if you were to answer this question, you would write sine of 315 degrees equals negative root 2 over 2. However, I want you to realize that these are the answers not only for 315 degrees, but also for negative 45 degrees. And 45 degrees is going to be one of our really useful reference angles, and we'll talk about that a lot more in the next section as well. And remember, it's negative 45 degrees because I start at my initial side and I go clockwise with my angle, so it's negative 45 degrees. So you could say that negative 45 degrees and 315 degrees are coterminal angles, and they have the same set of 6 trig functions. Some of the problems that we're going to see in this section as well are going to ask you to evaluate without a calculator. So let's try some of these examples. So in our first example, it wants you to evaluate sine of negative 210 without a calculator. So what I do is I think, okay, in my head I think, well, I'm actually going, it's negative, so I'm starting my initial side, and I'm really going clockwise. So I'm going the opposite way. I know that's 180, and then I know if I go 30 more degrees, I get to negative 210 degrees. Well, this is pretty hard to evaluate, and actually this way is still pretty hard to evaluate. However, I know that I could draw a triangle, and I know this degree measure is 30 degrees. So what I'm going to do in my head is I'm going to say, well, this is really the sine of 30 degrees. They're going to be pretty similar. And I know that the sine of 30 is 1/2. And then I'm going to have to decide, is it positive or is it negative? And here's my trick to deciding if it's positive or negative. My trick is, if this is quadrant 1, 2, 3, and 4, we can name them in this order. Now, how on earth are you going to remember A, S, T, C? We have one of these little crazy acronyms for it, and what I hear a lot of times is, and this is how I learned it, and this is how I'll always remember it, all students take calculus. And what this means is that whatever letter is there is what's actually positive in that quadrant. So in quadrant 1, all of the trig functions are positive. In quadrant 2, only sine is positive because it's an S, so only sine is positive. In quadrant 3, only tangent is positive, and in quadrant 4, only cosine is positive. So since this angle, negative 210, is in quadrant 2, I know that sine is going to be positive. So I know that I'm going to have positive 1/2. Let's try another one. So this time, and I'll go back to blue here for my example, this time they want you to evaluate tangent of 5 pi over 3. Okay, So I'm positive here, so I'm going to draw my axis, and it's a positive 5 over 3. So I'm going to start with my initial side, oops, and I'm going to go 5 pi over 3 radians to get to about here. And I know that this angle now is 60 degrees. So I know that this is really kind of like the tangent of 60 degrees. And we'll talk about how you can know these as well. And I know that if I have a 60, 30, 90, or 30, 60, 90 is the way we usually say it, a 30, 60, 90 triangle, I know that if this is 1, then my radius is 2, and my height is the square root of 3. So that means that the tangent of 60 degrees is really root 3 over 1, which is actually really the same as just root 3. But now we need to decide, is it negative or is it positive? So I'm going to go back up here to my All Students Take Calculus, and I can see that I'm in the 4th quadrant here, and in the 4th quadrant, only cosine is positive. So that means that this tangent must be negative here. So it must be negative root 3 over 1, or negative root 3 for an answer. Okay, so this is where we're going to see some undefined angles. So what happens when the angle lands on the axis itself? Sometimes it's going to be 0. One of our values is going to be 0. So let's see what happens. So I'm going to start with the sine of negative 270 degrees. So I start with my initial side, and I go 180 plus another 90. That's negative 270 degrees. So now I'm at this point, and I'm going to say my radius is 1. So this is 0, 1. Well, I know that if I'm doing sine, and we wrote those down, so sine of trig functions for any angle is my y value over the radius. Well, my y value is 1, and my radius is 1. So that means that sine of negative 270 degrees must be 1. That one was pretty easy. Let's try one that's a little bit harder. So this time I want you to find the tangent of 3 pi. Tangent of 3 pi is going to be a little bit different. I'll go back to pink here. So I'm going to start here, my initial side, and I'm going to go 3 pi's. So that's 1 pi, that's 2 pi's, that's 3 pi's. So now this is 3 pi radians. I've gotten all the way to this point right here, and I can see that this point is negative 1, 0. So I'm going to do the same thing. If you look back to in your notes for tangent, we said that tangent is always going to be y divided by x. And y divided by x in this case is going to be 0 divided by negative 1. 0 divided by anything is 0. So the tangent of 3 pi is 0. And I have one more example. What if I take the secant of 11 pi over 2? So now I'm going to start here. It's positive, so I'm going to start here, my initial side, and I'm going to say, whoops, this is really kind of like 11 pi over 2 is kind of like 5 pi plus a half of a pi, right? So this is like, I'm going to go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, half of a pi. So I'm going to end up here, and this point is 0, negative 1. And if you look back in your notes for secant, you would see that it's radius over x. My radius is always 1, and my x value this time is 0. Since we're not allowed to ever divide by 0, we say that this is undefined. Alright, so now we're going to be starting to talk about the dreaded unit circle. So the unit circle is a circle of radius 1. So we know that this line right here is actually 1, has a radius of 1. It's also centered at the origin. So most of what we've been doing is centered at the origin, but now we're talking about on the coordinate plane itself, radius 1 centered at the origin. These 6 functions are always true. Since we're no longer using triangles, now trig functions are being applied to real numbers, and we can call them circular functions. So x is a real number, y is a real number, t is some real number. An important property of circular functions is that they are periodic. So we're going to talk about what it means to be periodic. Alright, this might be a little bit confusing at first, but let's take it one step at a time and then we'll talk about what it means. So, a function, like y equals f of t, is periodic if there is a positive number c such that f of t plus c is equal to f of t. The smallest number c is called the period of the function. So let's talk about what that means in an example. For example, let's take sine of 57,801 pi divided by 2. Well, this is really the same as the sine of pi over 2, and really I should have written sine here, sorry. Sine of pi over 2 plus, because this is 1 pi, so now I took 1 away from this, I'm going to have 57,800 pi over 2. And then we can reduce that even, becomes the sine of pi over 2 plus 28,900 pi. And that's really the same as the sine of just pi over 2, which is equal to 1. Why is that true? Well, that's true because, let me change the color here really quick, 28,900 pi is a multiple of 2 pi, right? So since 28,900 pi is a multiple of 2 pi, we can say that they wrap to the same point. Remember when we had the coordinate plane and we said this is 1 pi, 2 pi. It goes to the exact same point. This would be 3 pi, 4 pi, 5 pi, 6 pi, 8 pi, 10, 12, 14, 16, 18 pi. And if I kept doing this over and over and over and over and over, eventually I would get to 28,900. Now I'm not going to sit here and do that, but since it's an even number, we know that it's going to wrap to the same point. So if I did this over and over and over until I got to 28,900 pi, all I would need to do is then go just pi over 2, or a half a pi more. And since we know that 1 pi ends up being over here, half a pi would just go to right here. And the sine of this point, we know, is 1. Or 1 over 1, we've already talked about this one. So it's equal to just 1. So you are going to need to learn the unit circle, but we'll talk about ways to memorize it without actually memorizing it in class. However, if you want to sort of get started on that and take a look at it so you at least know what it looks like, I know you've probably talked about it before, but if you want to look at it, I do have a picture of it up here. You can sort of copy down some of this, and we'll talk about these as well. And these all represent, I don't think it's going to let me write on here. Nope. These all represent degrees as well. So you can see that this is actually 30 degrees, this is 45 degrees, this is 60 degrees, and then 90 degrees up there. But we will talk about ways to memorize this without actually memorizing it in class. And that's it for this section. Thanks for watching.